The first use of jet propulsion goes back to the 13th century, when fireworks went off. Fireworks gradually progressed to propel weaponry, soon causing this technology to stop advancing for hundreds of years. Alpile was the first concept of a jet engine. The jet engine soon progressed to turbojet and ramjet propulsion. The first gas turbine to work was built in 1903, but wasn't sent to the manufacturers due to safety and cost. Finally, in the 20th century, like 7 centuries later, Sir Frank Whittle came up with the idea for a jet engine, bringing back the concept from fireworks. Whittle started a revolution in aircraft engineering as he knew it. Throughout the rest of Whittle's life, he saw the jet engine industry grow into a multi-million-pound industry. Based off his ideas, many aircraft engineers began to make his idea become real. Intercontinental flights became more practical, faster, and safer to use. Whittle's jet engine soon progressed to supersonic speeds. Supersonic aircraft goes faster than the speed of sound. This type of aircraft is mostly for military or experimental aircraft use. The aerodynamics of supersonic flight is called compression flow because of the compressions with the shock waves created by the aircraft. Afterburner is a component of some jet engines, mostly military. The purpose of the afterburner is to increase thrust for supersonic flight and takeoff. Afterburner injects additional fuel into the turbine, causing high fuel consumption and inefficiency, though generally regarded as acceptable for short periods of time. Jet engine thrust is governed by the general principle of mass flow rate. Velocity of the exhaust gas is from the afterburner. Mass of the exhaust gas is from the turbo engine. This creates more gas at slower speeds. It is highly fuel efficient and can deliver high thrusts for long periods of time. With the development of the gas pipe engine, realization of the piston engine being self-limiting came into play. The piston engine only decreased in efficiency when the blade tips of the propeller reached the speed of sound. This then led to propellers being used less when trying to build planes that travel at faster speeds. Aircraft engineers began to move towards planes without external propellers and towards planes with turbines. By the 1950s, piston engines were almost never used with the exception of cargo flights. In 1928, Albert Fano, a Hungarian mechanical engineer, was the first to patent a ramjet engine. Evolution of the jet engine soon began to revolutionize from the Gloster E-2839, the first British aircraft to fly with a jet engine, to the Heinkel He-178, a fixed-wing aircraft. The Heinkel He-178 was the first practical jet aircraft and the first to fly under turbo jet power. Over time, all fixed-wing planes became based off the design of the axial flow engine.
The Bell X-1 was the first plane to travel over Mach 1. It used a rocket fueled with liquid oxygen and ethanol that generated 6,000 pounds of thrust.
Wait a minute, I thought this was a presentation about jet engines. Why don't you stop talking about rockets and talk about something relevant to the presentation?
Well, a rocket isn't too far off from a jet. The only difference is a simple matter of what provides the oxygen for combustion. You see, a jet uses oxygen in the atmosphere, while a rocket has oxygen added directly in the fuel line, allowing it to fly at much higher altitudes. The X-1 series of aircraft was continued with the X-1A, then X-1B, X-1C, X-1D, and finally the X-1E, improving slightly from one to the next.
The X-43A was part of NASA's HyperX program. It, like Bell X-1, was part of the X-plane series. Its top speed was a whopping Mach 9.6. To achieve such insane speeds, it used a scramjet, or supersonic combustion ramjet, for about 10 seconds, followed by a 10-minute glide, and intentional crash into the ocean. I mean, it's not like it could have landed anyway. It wasn't designed with any landing gear. They had to actually drop it from a plane to get it going. But that isn't really important, is it? It's fast, and that's really all that matters, right? Anyway, it was succeeded by the X-51, which isn't as fast, but it still goes over Mach 5, which means it's still a hypersonic plane. And the purpose of developing the X-43A and the X-51 was all to develop hypersonic missiles, which are supposed to be in development around the mid-20s.
How does a jet engine work? It's actually not that complicated. First, air enters the engine through spinning blades, which is then fed through the compression chamber, the air gets compressed, and then gets pumped into the combustion chamber. In the combustion chamber, fuel is added into the engine and reacted with the oxygen. This produces a lot of hot gas, which is then forced through the turbine, spinning it, causing the blades to move, and then it exits the engine as exhaust. If the engine is equipped with an afterburner, then fuel is added directly into the exhaust, which provides extra thrust.
So, what is a sonic boom? A sonic boom is the sound associated with an object traveling at or faster than the speed of sound in normal atmospheric conditions, or Mach 1. Sonic booms are caused by a series of pressure waves in front of and behind an object. These waves can travel at Mach 1, and as the speed of the object increases, these waves are forced together and compressed into a single shock wave, which can even have enough force to shatter glass at close range.